Terrence Howard is about to lift the veil on a 6,000-year-old secret, one that mankind has been trying to decipher for thousands of years. What we're about to uncover is not just surprising, it's transformative. So sit tight and let's dive in.
I want you guys to know about a 6,000-year-old secret. 6,000 years, mankind has been trying to decipher this one little thing called the flower of life. Have you guys ever seen this before? Now, you know this is one of the oldest symbols in human history, right? This symbol was found in the Temple of Osiris in Egypt, and it had been molecularly burned into the wall. And it's 6,000 years old. This same symbol has been found in the forbidden temples in China, sitting under the fufu dogs. And the foot on it, the flower of life, saying whoever controlled that flower of life controlled the universe. There were secrets in that flower of life that Vinci spent his whole life trying to uncover. There were secrets in that flower of life that Newton spent his whole life in secret trying to uncover. The same secrets that Pythagoras was desperately trying to uncover. But their problem was they kept seeing this in a two-dimensional space. They couldn't get it out of this two-dimensional frame, and as a result, they got stuck in this plane, a flat plane. Now, what Da Vinci and all of them wanted to do, they were trying to find a way to bring this flower to life, because what is inside of it? Well, apparently, there were secrets inside of it. Shapes, they got the Merkaba and all of those other things out of it. But they were misled by something I think called a straight line. You guys believe in straight lines? You believe there's straight lines in the universe? Well, let me hit you with something. All energy in the universe is expressed in what? It's in motion. If something is still, there's no energy. Kinetic, right? All motion is expressed in what? You look at galaxies, are they expressed in straight lines? Expressed in vortices. All vortices are expressed in what? Waves. All waves are curved. Show me a straight line in nature. You show me where the platonic solids come from. Where do they have their foundations in our universe? Are there any straight lines? If you look at anything, there are no straight lines. That's been the mistake. We've been looking at these straight lines, this Euclidean way of thinking, and missing the curvature of nature. So here we are, back with the curvature of nature. And you have all these little pieces. Now, this has always been an information system. So compare some of these points. Take a point here and say, well, what's the space in between all of these things? Now, they've said that all the in-between spaces, if this is the Earth and this is the moon right here, all this in-between space is filled with what? A void. There's nothing in the void. Well, I found that there is something in the void. The elementary fundamental particles that they've been searching for at the CERN collider, the Hadron Collider in CERN, I found that their energy signatures matched perfectly to some of the pieces that I was able to pull out of here.
Terrence Howard's captivating speech on the flower of life not only draws us into a world of ancient mysteries, but also encourages a profound reevaluation of geometric understanding. His assertions, far from mere speculation, find resonance in a tapestry of historical, scientific, and philosophical contexts. As we delve into the 6,000-year-old secret of the flower of life, we uncover a journey that intertwines the quests of great minds like Da Vinci, Newton, and Pythagoras with the modern rethinking of geometry. The flower of life, an intricate symbol composed of multiple evenly spaced, overlapping circles, is more than just a mesmerizing design. It's a portal into the ancient understanding of the universe. Its presence in the Temple of Osiris in Egypt and in hidden temples under the watchful eyes of food dogs in China signals a universal reverence. This symbol, believed to represent the fundamental forms of space and time, is a visual expression of the connections life weaves through all sentient beings, hinting at the underlying unity of the cosmos. Terrence Howard's admiration for the symbol is not an isolated phenomenon. History tells us of great minds who also pondered over its significance. Leonardo da Vinci, a polymath of the Renaissance era, is known for his extensive studies of the flower of life. Da Vinci's sketches reveal his fascination with its geometric perfection and potential to unlock the secrets of the universe. Similarly, Sir Isaac Newton, in his quest to understand gravitational force and the mechanics of the cosmos, delved into ancient knowledge and symbols, including the flower of life. It suggested that Newton's famed discovery of gravity was part of a larger pursuit to decipher the cosmic puzzle embedded in ancient symbols. Pythagoras, the Greek mathematician, also journeyed through these mystical realms, using geometric principles to understand the harmonies of music and the structure of the universe. But what Howard brilliantly highlights is the limitation these great minds faced, their confinement within two-dimensional perspectives. Despite their genius, they grappled with the symbol's profundity, unable to fully transcend its planar representation. This is where Howard's critique of traditional Euclidean geometry opens a new avenue of understanding. Euclidean geometry, the bedrock of much of our mathematical and scientific understanding, focuses on flat, two-dimensional planes. However, the universe, as Howard eloquently points out, isn't confined to flatness. It's a dance of curves, waves, and multidimensional forms. The flower of life thus becomes a gateway to understanding the curvature of nature. When we look at the spirals of galaxies or the intricate patterns of a nautilus shell, we see not straight lines, but curves. This realization has profound implications. It suggests that the universe operates not just in the realms of the flat and linear, but in dimensions that our ancestors possibly tried to communicate through symbols like the flower of life. Howard's speech resonates with the modern scientific understanding of the universe. The curved space-time continuum, a fundamental concept in Einstein's theory of relativity, echoes this ancient wisdom. The curvature of space and time around massive objects like stars and galaxies isn't just theoretical, it's observable. The warping of light around massive objects, known as gravitational lensing, is a testament to the universe's curved nature. Furthermore, Howard's insights find parallels in the realm of quantum physics. The elusive nature of elementary particles, their existence in probabilities rather than definite positions, aligns with the idea of a universe beyond straight lines and predictable paths. This is where Howard's theory about finding something in the void becomes particularly intriguing. The void, often thought of as empty space, could be teeming with these fundamental particles, invisible threads weaving the fabric of the universe. The flower of life, therefore, is not just an ancient symbol, but a representation of the universe's deepest secrets. The 6,000-year-old secret isn't just about a geometric pattern, it's about the very nature of reality itself. It's a symbol that has transcended millennia, bridging the gap between ancient wisdom and modern scientific understanding.
I've spent 45 years searching these things out and trying to figure out what the universe really, how it really worked. And we've come to find that the universe, they are abandoning the standard model, the ideas of black holes and dark matter, for an electric model of the universe. There's tons of paperwork of Da Vinci working on the flower of life and trying to unravel it. But every single existence, every single example, you see him making straight lines and trying to make these straight lines bend in, and therefore he was never able to open it up. Because the universe is curved, all space is curved. And as a result, what I was doing in trying to find these straight lines, I abandoned the idea of the straight line. The shortest distance between 2 points is curved space, because you cannot force your way straight through space. Even electricity, as it moves from a southern plane to a northern plane, it always goes northeast in its direction. And magnetism, as it expands out, it goes southwesterly. And that's the spin. That's how you always know whether it's magnetism or electricity. It's the spin. Is it northeast or is it southwest? But in trying to define the spaces, it allowed me to see that all of these in between, what we have been dealing with is these petals. All of mankind have dealt with these petals, but is these other shapes that we've ignored constantly. Well, those other shapes were the in-between spaces. They were the things that filled up the vacuum of space. And all these particles that I have, I think are the full proof of that. And it is also the full proof of the wave particle argument.
Building on Terrence Howard's profound insights about energy and motion, we embark on a journey to unravel the universe's hidden language, a language articulated not in straight lines, but in dynamic patterns and ceaseless movement. This exploration leads us into the realms of modern physics, where the concepts of energy and motion are understood not as linear trajectories, but as complex interplay of forces and fields. In the heart of this exploration lies the fundamental principle that all energy in the universe is in perpetual motion. This motion manifests in vortices, waves, and spirals rather than straight lines. Modern physics, with its study of galaxies and celestial bodies, supports this view. Galaxies do not arrange themselves in straight paths, but in swirling spirals and elliptical orbits, a pattern mimicked in the structure of the DNA helix and the spiraling arms of hurricanes. Howard's perspective resonates deeply with this view, suggesting a universal pattern of motion and energy that is curved and cyclic. The wave-particle duality in quantum mechanics, a concept that posits particles as both discrete entities and probabilistic waves, further illustrates this departure from straight-line thinking. This duality challenges our conventional understanding of motion and trajectory, proposing that at the fundamental level, the universe expresses itself in probabilities and patterns that defy straightforward categorization. Moving from the macrocosmic to the microcosmic, we delve into nature's curves, seeking the essence of the universe. This chapter explores how the natural world embodies the curved, non-linear geometry that Howard emphasizes. From the majestic sweep of rivers to the delicate curl of a fern's frond, nature abounds with curves and spirals. These patterns are not arbitrary, but follow mathematical principles such as fractal geometry and the Fibonacci sequence. Fractal geometry, with its self-repeating patterns, offers a window into the infinite complexity of nature. These fractals are evident in the branching of trees, the structure of snowflakes, and the rugged contours of mountain ranges. The Fibonacci sequence, another mathematical pattern, manifests in the arrangement of seeds in a sunflower, the spirals of a snail's shell, and the proportions of the human body. These patterns reveal a hidden order in nature, an order that transcends the straight lines of Euclidean geometry. Howard's perspective on the absence of straight lines in nature aligns with these observations. By recognizing the curved and recursive patterns that govern the natural world, we gain insight into the essence of the universe. These patterns are not mere coincidences, but are reflective of deeper, universal principles that govern the growth, structure, and movement of everything in the cosmos. As we delve deeper into this exploration, we prepare to encounter a concept that further challenges our conventional understanding of mathematics and its application to the physical world. Terrence Howard, in his insightful speech, introduces us to a fascinating aspect of this hidden order, the concept of mathematical loops. This intriguing idea, exemplified by the looping behavior of the square root of 2, reveals an unexpected and seemingly paradoxical nature of mathematical operations.
But all of these wave conjugations, all of these states of matter, all of these things, it's time for that to be changed now. We have changed all of our buildings to be aerodynamic. Our airplanes are no longer based on a two-dimensional Euclidean way of life. But our math is still based on a two-dimensional way. And I think in order for us to reach the future, we have to examine that. Do you guys know about loops in math? Do you believe in loops? Do you know the square root of 2? Do you think that's a loop? Do you believe that the square root of 2 is the square root of 2? I want y'all to take out your phone for a minute then. We're gonna do one thing. Put it on the calculator and turn it to the side so you can get all the long numbers out of it. Now I want you to put in 2 and square root it. 2, hit the square root, you'll get 1.414213562373095 ... right? Now I want you guys to do me a favor, cube it. It'll see right over there, it'll be x to the 3. It'll see 2.828427121746190. Now that makes sense. I want you guys to do me a favor, divide it by 2. Got that number? Cube it again, divide it by 2, cube it again, and I want you to do that until the end of your lives. And that number will still come up with 2.828427121746190. Any other number that above 2, that you put in and you cube and you square, cube and square and divide by 2, by the 6th operation, it has moved into an exponential number that you can't even imagine. Any number below 2 that you do that same operation with, it will go into an exponentially small matter and number. This is what we call a loop. It is illogical, It doesn't make sense, and it does not make math make sense. So these are some things that I'm bringing to the fore and that I would like to question. I would like to audit the math, the world of mathematics, and I would like to audit how we view the Platonic solids, because I think the new wave conjugations will tell a better story of how our world works.
Terrence Howard's speech takes an intriguing turn as he delves into the concept of mathematical loops, challenging our conventional understanding of mathematics and its application to the physical world. His example using the square root of 2 not only captivates, but also invites us to reconsider the foundational principles of mathematics that we often take for granted. Howard's call to audit the math is more than a mere suggestion. It's an invitation to embark on a journey of discovery and reevaluation of the very fabric of mathematical understanding. In his example, Howard demonstrates a fascinating loop with the square root of 2. By continuously cubing and dividing the result by 2, we arrive at a constant value, 2.828427121746,190. This phenomenon, as Howard points out, defies our expectations of mathematical operations, where we anticipate a change or progression rather than a loop. This loop is not just a numerical curiosity, it represents a deeper, perhaps fundamental, aspect of mathematical reality that has been overlooked or misunderstood in traditional Euclidean mathematics. Howard's exploration into these loops hints at a larger, more profound implication, that our understanding of mathematics and its relationship to the physical world might be limited or even flawed. He suggests that just as we have adapted our buildings and airplanes to be more aerodynamic, moving away from two-dimensional designs, it might be time for our mathematics to evolve as well. This evolution would mean embracing concepts that might seem illogical or counterintuitive, such as these mathematical loops, and integrating them into our understanding of the universe. The significance of Howard's call to reevaluate the Platonic solids and their role in understanding the universe cannot be overstated. The Platonic solids, the tetrahedron, cube, octahedron, dodecahedron, and icosahedron, have been central to classical geometry and philosophy, symbolizing the elements of fire, earth, air, water, and the cosmos. However, Howard suggests that there might be more to these shapes than meets the eye, especially when viewed through the lens of wave conjugations and mathematical loops. This perspective aligns with the emerging field of quantum geometry, where the traditional rules of Euclidean geometry give way to a more dynamic and complex understanding of shapes and structures at the quantum level. In this realm, the behavior of particles and forces cannot be fully explained by straight lines and flat planes. Instead, they exhibit behaviors that are better understood through concepts like Howard's mathematical loops, where values loop back on themselves in ways that defy our conventional understanding. Howard's challenge to the world of mathematics is not just a mathematical query, it's a philosophical and scientific proposition. It calls for a re-examination of the fundamental principles that govern our understanding of reality. By questioning the validity and completeness of current mathematical approaches, Howard is advocating for a paradigm shift, one that could lead to a more profound and accurate understanding of the universe. In essence, Terrence Howard's speech is a catalyst for a broader conversation about the nature of reality, mathematics, and our perception of the universe. His insights into mathematical loops and the square root of 2 open a gateway to exploring the universe in ways that transcend traditional boundaries. They invite us to consider the possibility that the universe is far more complex and interconnected than we have previously imagined. As we continue to explore these ideas, we may find that the answers to some of the universe's greatest mysteries lie not in the straight lines and flat planes of old, but in the loops, curves, and multidimensional spaces of a new mathematical understanding.
Our planet is moving away from our sun at 6 inches a year. You guys know that. 15 centimeters a year, our planet is pushing away from the sun. So in less than 500 million years, our planet will be out of the Goldilocks zone. We'll be somewhere near where Mars is, somewhere halfway between there. So life will not be able to be sustained on this planet anymore. So if we're going to be able to sustain ourselves as a species, we have to become interstellar. Not just interplanetary, you have to become interstellar. But with approximations, you cannot become interstellar. You cannot become interstellar with a point that will take you all the way over here with a straight line when the actual event is taking place over here. When you're going 600 quadrillion miles, you can't make a mistake. You need precision. And that's what the math is about. These pieces predict the natural distribution of matter and the distribution of where you can find yourself in that space. And I'm confident behind it. For 40 years, I've worked on this. And I think it's ready.
As we conclude this incredible journey, it's clear that Terrence Howard may very well be a genius in his own right. His insights have opened our eyes to possibilities we never imagined, challenging us to think deeper and look beyond the obvious. Seeing him in this new light as a visionary thinker gives me hope. It suggests that humanity, with its endless curiosity and capacity for understanding, is on the cusp of new, groundbreaking discoveries. Terrence's passion and intellect remind us that every one of us has the potential to unlock secrets of the universe, pushing the boundaries of what we believe is possible. So let's carry forward the spark of inspiration, fueled by the promise of what humanity can achieve.